Hi everyone, this is the video for Algebra Section 9 Inequalities. In this video I'll give an overview of the topic, I'll then go through the worksheet and finally I'll answer the questions that are on the worksheet. The description box below gives a link to my Instagram page. Here you can find images of the worksheet as well as the answer page. Inequalities tell us when certain expressions are greater than or less than, or greater than or equal to, or less than or equal to another expression. The way to remember which way around the inequality should be, or should be read as, I remember them as crocodile heads, I'm sorry. So the crocodile only probably wants to eat the biggest meal, the biggest piece of meat. Therefore, the bit that the crocodile wants to eat is the side, is the expression that's bigger. That's how I remember it, bear with me. So if you know how to handle equations that have equal sign, nothing's different here. It's just that instead of the equal sign, we're just going to have an inequality sign. So instead of equality, we're going to have inequality. But that doesn't mean everything you've learnt goes out the window. All those things you've learnt still hold. It's just that the relationship between the expressions is slightly different. So in this video, I'm just getting used to the fact that we might not have an equal sign every now and again. We might have an inequality and it's all good. So let's get into the worksheet.
Right. Here is the worksheet for Algebra Section 9. As I've said, there isn't any extra learning or remembering needed in this section. It's more about familiarising yourself with something a little different and showing you that you already have the skills to work through the problems on this worksheet if you've followed all my previous algebra topics, in particular Section 6 on rearranging. Let's get started. If you have two expressions, e.g. a squared plus b squared and c squared, you can connect them by an equal sign here. By doing this, you are declaring that these two expressions are equal. The whole statement can then be referred to as an equation. An equation asserts the equality of two expressions. These three here are all examples of equations. The equations are telling us that these pairs of expressions are equal. The most obvious one is this. 0.5 is equal to a half. We all know that. Inequalities are in the same league as equations. Inequalities assert the inequality of two expressions. This is done by connecting two expressions by an equality symbol. There are four types of inequality symbol, which I'll go through here. Let's start with this one here. We have a less than equality symbol. That's this symbol here. This is telling us that one expression is less than the other. In this inequality symbol is telling us that 3 is less than 4, which we know is true. Notice what I said in the introduction. If an equality symbol is thought of as a crocodile head, this guy here, you can remember which way around to write the inequality symbol if you think of the crocodile as always wanting to eat the thing that's bigger, i.e. its mouth is going to point to the bigger expression. So here, 4 is bigger than 3. That's how you can try and remember which way round to write them. Over here, we have a greater than inequality symbol. This tells us that one expression is greater than the other. This is telling us that 5 is greater than pi. And we know pi is 3 point something. So yeah, we know this. The next two symbols are similar to these previous two. We have a less than or equal to and a greater than or equal to inequality symbol. We can think of these as a bit like a hybrid between equal sign and inequality signs. So this symbol here, less than or equal to. This tells us that one expression is either equal to or less than another expression. So here, this is saying A is less than or equal to A squared. Let's try this out with some numbers instead of letters. So imagine A was actually 2. We would have 2 is less than or equal to 2 squared. 2 squared is 4. Therefore, this becomes 2 is less than or equal to 4. Well, we know this is true because 2 is less than 4. Let's think of another number. What if A is actually 1? This would become 1 is less than or equal to 1 squared. 1 squared is 1. Therefore, this would read 1 is less than or equal to 1, which again is true because 1 is equal to 1. It just so happens that for any other integer value of a, this inequality holds. So we know something about inequalities. How about we practice solving them? Remember, to solve an equation, you must have the subject on one side of the equal symbol and everything else on the other side. The same holds for inequalities. To solve an inequality, we can use the steps we learned in Algebra Section 6 Rearranging to get the subject on one side of the inequality symbol and everything else on the other side. Let's look at this first example here. To solve the inequality x plus 3 is less than 4, we must get x on one side of the inequality symbol and everything else on the other side. To do this, we need to move the plus 3. The way we do this is to subtract 3 from both sides to get the following. Now all we have to do is simplify and we get to the solution. The solution is x is less than 1. Sometimes I like to draw a number line to show what this solution actually looks like. This is an integer number line. And this solution is saying x must be less than 1. This dotted line here represents that x can be anything less than it. If x could be equal to 1, this would be a solid line. I always like to check my answer as I do tend to rush through some things and make mistakes. To do this, I test out some values of x. Specifically, I set x to a value that the solution says it can be and check that the original inequality holds. I then set x to a value that the solution says it can't be and check that the original inequality fails. So the solution says that x has to be less than 1. Okay, let's see if the original equality up here holds if x is 0. So x becomes 0, therefore this side is 3 and this side is still 4. Therefore, the original inequality says 3 is less than 4. Well, this is true. Okay, now let's see if the original inequality fails if x is 1. The original inequality is this. If x is set to 1, then this side becomes 4 and this side is still 4. So the original inequality says 4 is less than 4, which doesn't make sense. Therefore, x cannot be 1. So from testing these two things out, we can see that, yeah, x seems to work on this side of the number line, but not on this side. Therefore, I'm happy with my solution that x is less than 1. Let's look at the second example. Here it says solve minus 2 is less than or equal to x over 2 minus 1, which is less than 5. Don't flip because there are now two inequality symbols. Just follow the usual steps. The first is to sort out the fraction. After multiplying every term by 2, we get the following. Now we need to get x on its own, so we need to add 2 to every expression. Finally, we can simplify to get the following. This is our solution. X is greater than or equal to minus 2 and x is less than 12. Again, we can draw our number line to represent what x can be. So here it has to be less than 12, therefore we get the dotted line, but it can be greater than or equal to minus 2, so we get the solid line. Once again, it's good to check that this solution is right. Now you can go ahead and check this part. I've already checked it. I'm happy with that. Let's have a look at this example now. Here we have solve x squared minus 25 is less than or equal to 0. Again, we need to follow our rearranging rules. We need to get x squared on its own. To do this, we add 25 to both sides. So there we go. Okay, we need to pause a minute here before we go on to the next step because there's something really important to remember when you're dealing with squareds. If we had actually that x squared equals to 25, what we need to ask ourselves is, okay, what number squared gives 25? Well, we know that 5 squared is 25, so that must be x. However, there is another solution. If you had x as minus 5, this would also give 25. Because minus 5 times by minus 5 is 25. Like a minus times a minus is a positive. So that positive cancels out, so you get 25. Therefore, we could have a minus 5 here or a plus 5 here. What that means for inequalities is when we square root this and write it down on the next line, we have to have two inequality symbols because we have to account for the fact that x can be minus 5 as well as plus 5. Now, if we work out the square roots, we get the following. This is the solution. Here's the number line to show what x can be. And the final example, solve minus 2x plus 3 is greater than 15. Once again, we need to get x on its own, so we need to subtract 3 from both sides. Now we need to remove the minus 2 in front of the x. How do we do this? We divide both sides by minus 2. Now one really important thing you have to remember with inequalities is if you are timesing or dividing by a negative number, the inequality flips round. So this inequality becomes x is less than 12 divided by minus 2. You see this inequality has flipped around. And so x is less than minus 6. Now if you don't like remembering that, you can do something very different. Instead of dealing with a minus 2, what you could do is take this whole term to this side and take this 12 to this side. So what you would get is you'd get a minus 12 on this side and you'd get a positive 2x on this side. Now then you would divide both sides by 2, so you get minus 12 divided by 2 on this side and an x on this side. Minus 12 divided by 2 would be minus 6, and then you would have an x on this side. So you'd be saying minus 6 is greater than x, which, look, is the same as this solution down here. I.e. you get the same solution, but you don't have to deal with that minus sign and switching signs around. But it's probably best to just remember that and be able to do it really quickly. So 2 main things to remember with inequalities really. When you've got a square, your inequality will split out, i.e. you'll get 2 inequality symbols because you can have 2 solutions here. And the second thing to remember, when you are dividing or timesing by a minus number, the inequality symbol flips around. Right, this is probably a good point to pause the video, try out these questions here, and then come back to the video and you can compare your answers as well as your workings. Thanks.